This is going to be a little bit of a long video, so go ahead and take a look at the screen, see if you got that amount of time to be engaged here. It is going to be a lot of visual as well. If you don't have that amount of time, you can save it to watch for later. Also, it's expecting that you have some knowledge, not necessarily expertise, not necessarily experience, and not necessarily in C or C++, but it is expected that you have some basic programming knowledge, at least on the basic concepts of how a program works in general. And if you don't have that, you can save this to watch for later. Go into my channel and see some of the videos in there that are about the basics of programming. I have some of them there that are in there. There's just a basic rudimentary concept of how a program functions. So take a look at that, and if you're already experienced on this, then this is probably going to be rudimentary. This is going to be a lot about basic command line programs, CLI type environment, command line interface, and it's going to be about getting you able to write basic C and C++ programs. This is going to be a double tutorial because the languages of C and C++ are so similar, but they're also different. So we're going to be doing a C tutorial, we're going to be doing a C++ tutorial, and at the same time also a comparison. So kind of a triple video in a sense, a double tutorial and a comparison. So let's take a look at some of what C and C++ are, since this is a little bit different here. Things to know. C is on the low level. Low level means machine code. How does the machine think? What's the machine's language? How close is it to what the machine does? And high level is how close is it to a human and how a human thinks and how a human talks and interacts. C++ is in the mid-range, and C is more on the low range. A lot more rudimentary on the C. You don't have as many of the higher-end options for the lower-end C stuff. And they're both compiled languages, so they're not platform independent or any of that. They are going to be compiled to your architecture on your processor for your operating system, which means that they also run pretty fast. C, I understand, runs typically a lot faster than C++, and C compiles faster as well. It has a few simplifications to its language, which makes it compile a lot faster, become a smaller program in less time. But the cost is it's harder on the programmer. So it doesn't have any bells, it doesn't have as many bells and whistles in the program. In the programming language, it falls more on the programmer to make up for that. They're both very powerful, and they're both used in many program types. Command line interface, which is what we're going to be looking at here. Console user interface, which is more the advanced GUI, advanced terminal, and then you've got the graphical user interface, or GUI, like windowed programs. It can also be used for CGI applications, which is on a web server. Not all of the pages are sent as static pages. Sometimes they're created dynamically on the fly, and sometimes that's done by a script, and a lot of those scripts actually run by some type of a CGI executable that runs a script. That's the script engine. Or the CGI executable can actually be producing the page directly. And C can be used for either one of those. C has been used for many of those types of languages, used to create those scripts, as well as been used as an executable itself, to compile the actual executable itself up there. And if you're not familiar with those different types of interfaces, the CLI, the CUI, the GUI, I have a video that does compare those and explains those. So they both use the standard curly brace block format. meaning if you are familiar with many of the common languages out there, if you're familiar with any of the, there's many of them, that if you're familiar with any of those, you'll feel right at home here. Java, PHP, JavaScript, it's going to look very similar, and it's going to act in a lot of ways very similar. A lot of things will be, you can almost copy and paste the code from the other ones and make very few edits, and some of you won't have to make any edits. Just depends on what you're working with. Now, as far as encapsulation goes, encapsulation means that you have the ability to, encapsulation is great because it's good for error control. You can test out a portion of your program and make sure that it's bug-free. It's working the way you want it to. It's not going to be affected by things outside of that portion of the program. One portion works the way it's supposed to. You work on another portion, it works the way it's supposed to. Those are building blocks, and then you work with how everything else works together. Those things are just depends on which language we're dealing with. These are opposite end of the scale because of their minor little differences between C and C++. C has no encapsulation, and C++ has some of the best encapsulation. So, yeah, let's start taking a look and seeing what this code looks like. Like I said, this is a long video. The rest of it is going to be looking over a very long text file in here. And it is, just to get our perspective on that, 220 lines. A lot of these guys are going to be handled by groups, but it will be a little bit of a long video. So I'm going to go through this thing and describe. This was created for just academic purposes, so we aren't actually going to compile this because it's such a mutt between two different languages. It was created to demonstrate things. I'm not going to be compiling this. I don't even want to know what the compiler would think here if it saw this. But it will be enough to be able to point out different features of the different languages and explain what we're dealing with. So, includes. You got to include whatever libraries you need to, and this is an example of a C library, and anything that was from C, I don't know of anything from C that you can't use in C++. I haven't run into issues with that. If you wrote the program in C, you should be able to use a C++ compiler and even compile it as C++. But many C++ compilers also know C. Many of them are dual language. And that's why I've got this critter up here. This is a C++ file. This extension is what it's looking at. Even on Linux, the compiler will look at that and it will go, this is supposed to be C++, I should handle it as C++. If it is .c, then it's going to go, okay, you wanted to compile a .c file, I'm going to handle that as C and enforce the rules of C itself on there and compile it as if it was C. So that's something to take into consideration. On C files and C++ files, that extension does still matter. All right. So in include right there, that's the one that's compatible with both. It was designed for C. The one that was designed for C++ is only compatible with C++. And that's a common thing too. A lot of C++ stuff cannot be compiled with a C compiler. It doesn't go backwards. It goes one direction with this. So one of the biggest differences that really makes a difference here is IOStream, which is what this is, namespaces, and classes are not allowed in. They're not allowed. No, they're only allowed in C++. These guys, they're only allowed in C++. You can't use them in raw C. But now let's take a quick look here at namespace, a concept of namespace, because that's our next line in place here. This is commented out. Actually, I'm going to first look at comments, then I'll get back to namespaces. Two different types of comments. All these curly brace formats support the same types of comments. I haven't seen an exception with that yet. Here is a single line comment. Double slash means it's a comment till the end of the line. At the end of the line, it's now going to look at code again once I have a line drop. On slash star, it's going to look until finally I have a star slash. Everything in between those two, an easy thing is just to think about one of these nice starred out boxes and how nice they look. Thinking about the slashes, bracketing that in. So all of what's highlighted right there is a comment. That's a multi-line comment. So here we have, this is commented out, which means it's not going to run. When we deal with a compiled program, there's like 3 layers of what goes on. You have things that are user comments that are omitted. It doesn't bother with stuff, this is a comment. It ignored what I wrote there. If I tried to compile this, it would not bother me about that. This stuff here, it's commented out as well. It's not using namespace std. That's an abbreviation for standard. That's the standard namespace for a lot of stuff. But this guy here, that's one of the things which I was going to mention after we're done mentioning what happened. So we first got all the comments. It strips those out. Then it looks at compiler directives. That's what these include guys are. These guys are compiler directives. And there's sometimes some other directives too that you'll have. And they're things that can affect other things that get, say, included. It's going to grab these whole other header files and it's going to include them, and it's going to look for anything in them that needs to be other directives, and it's going to run through those directives. Once it's finally assembled everything into its memory page from its directives like that, then it can work on the compiling process for all your code, all of your stuff where you've actually written something that's supposed to be ran, this creating a struct, defining a struct, defining functions, stuff like that. Well, in that case, prototyping them. So let's just take a quick look now that we've described what happens during the compilation process. We're now going to take a look at namespaces. So in this case, here I say I'm using this. I can either say that, which I did not because I commented that out, or I could say every time that I need to, well, here it is. Here's a declaration of a namespace. So everything in here is under my namespace. I can create my own namespace there, which I did. And then over here I have some samples for input output, and this is where that standard namespace is. I can, by saying using namespace, I don't need this std::. That's saying that I'm entering that namespace, get me the cout that's a part of that namespace. Without this, it won't be able to find cout. Or without the using namespace. One or the other of those two needs to be active in order for it to be able to resolve that cout or cin class or anything else that's a part of standard. So that's the concept with that namespace thing. We talked about comments, structures. I'm sure we're going to revisit those later on, but this is to define a structure. Struct is an abbreviation for structure. And then this is the name of my structure. So I basically am creating a type. This is as close as you're going to get to a class in C. And when you're in C, this is as close as you're going to get. And then you can define the members in here and say, I'm going to have all of these different, in this case I just have a single int named num. So once I once I define something to be a part of that struct, then once I define that variable that is of that type, my struct, I can use a dot operator and call that num member out of that. Alright, function prototypes. Now this is important because, and we're going to look into functions more towards the end of this tutorial, but I did want to bring this up here, that if you try to call a function at any point in your code before it at least hits a function prototype, yeah, function definition is great, but if you can't get a full function definition in there, and I wanted those at the bottom of this, below my main function, and so if it's not, if you don't hit this before you try and call that, which they're called in the main function, so I had to have them up here, and so I would raise an error without at least prototyping that. So since my functions are way down here, I got function here and I got a function here, but my calls to them are up in here. So, that doesn't really do all that much good for me. That would be an error if I don't include these. And here I have my namespace, my class defined here, and we'll discuss classes a little bit further down the line too, and we'll discuss all those modifiers and how all that works. But that's the basic. Yeah, we're going to get down in here though. We're going to take a look at what happens to start. So besides those little directives and things like that up there, and the using statements and some definitions that happen up in here, it waits until it gets on over here to this main function. It's looking for a main function. It should be returning an int type, an integer type, and does not have arguments. This is my main function where everything begins, and I have two different styles on this for demonstrating input and output. The first one is a C compliant, and this one is C++ only. So on C, I am going to declare my string as a character array. That's what you use for strings in C, and you can use them in C++ as well. All those things that you use in C, I can't think of anything you use in C that you can't use in C++. So here I have it going out to say type something. Now in C, you have control over dropping the lines. I don't have a line drop here, so the cursor is going to sit right here on this, and then it's going to listen for a input on here, and once it inputs, it's going to put it over here in my string. It's looking for a string input, and it's going to put it over here in my string. It's going to set that character array to equal whatever that is, and in C, once you're done with the visible portion of that string, then it also has a null character at the end of that, which is \0 is what that's represented as. And so it's going to receive that, and then it's going to print out. And once again, you can't really print anything directly that's a variable. What you have to do is you have to say print this string, but these guys, we'll discuss them a little bit further down. This tells it that the string goes here, the first argument is a string and it's going to go here. I think I have some other ones too where I put in multiple ones of those after I explain that further. So C is going to be a little bit more temperamental with this. C++ is a lot simpler, and if you're a little bit lost, I'm sure it will come in another few minutes here where we'll discuss more about what these things are. And then, yeah, I mean, if you wanted to pause at any time, take a break too, that's another option too. All right, so here this is not allowed in C. It's only allowed in C++, and it's because it uses classes and namespaces. It uses something that's been put inside the namespace, the cout class. This is an insertion operator. I'm inserting this string literal into that class. And in C, you can define operators for your classes. And that's what they did with cout. It handles that operator to be able to take in a string and be able to output that string to the console. And so that's really what we did here. We just took that string and shoved it on over there. And the cool thing is it's not just strings. There's plenty of other stuff we can just shove on out there, numbers and whatever else we want to, straight on out to that cout. In Cn, up here, this is an extraction operator. This is now taking the input class that handles input, and it's got an extraction operator on it that allows me to extract from it to a string. And so, being that I had no line drop here, of course it's going to sit right there, and it's going to wait for my line input, CLI, waits till the line's input. Once I hit that enter, it's going to turn this into whatever was input. And then I'm going to come down here. Oh yeah, this is another option on how to do that as well. You could also use the getLine function, whereas then you pass it to Cn and then pass it to string. And the difference between the two is this, the first piece of white space, including a space. You know, let's say we're going to enter a full name, first name, space, last name. You know, it's going to take first, and it's going to stop where the first white space is on this Cn style. Now out here, it's going to get the full line. So two different styles on that. And so cout, right here we can see where we can do multiple extractions. This is a very good one to show on here. Multiple multiple insertion operators for this. So what this works as is it's going to take this string literal and send it out to the output. Then it's going to take this string and send it out to the output. And then it's going to take this string, which happens to be the inline character that you can use to make this to where you can compile it for whatever platform. If you choose different options on the compiler to say, hey, I want to compile this with Windows libraries for Windows, it's going to put the appropriate inline character for Windows on that. And then on Linux, it'll put the appropriate one for Linux. If you've got libraries for Mac, it'll put the appropriate ones for Mac. But that's the proper inline, is what that point is. So that's a but that's going to output that. So I'm going to be able to output that whole line there. You typed colon whatever my input was. That's wherever I got that. Or from this one. So two very different ways of doing that, but this one is a lot more flexible. You don't have to deal with these what do you call them down here? Format specifiers. You got to know a whole bunch of format specifiers, and using C as opposed to C++, it handles that for you. So in the end, C++ is a lot easier. I mean, 2 of these lines, of these 5 lines, are comments. So this would be 3 lines long to do this in C++. Well, this guy, actually one of them is the declaration deep down here anyway. But yeah, I mean, actually I could have done my declaration here probably. So yeah, anyway, it's simpler in C++. Alright, variables. There's all kinds of different variables, and some of them are allowed. And surprisingly, Boolean is not allowed in C. It's only allowed in C++. And, you know, you got characters that are just 1 byte. You've got shorts that are, you know, short integers. These guys here are for whole numbers, just different sizes of whole numbers. And then these guys here are for decimal numbers. And then string, to actually have that, see, this was of type character, and it was a array, character array that we defined there. And down here it's actually talking about string type. That's only allowable in C++ to use that because it is a class. You have to include the string include header, have to include the header for strings to be able to use that class. And that's why it only works in C++. So otherwise you're dealing with character arrays, which I don't think that's too big of a deal, but there are some real luxuries in working with true strings. There's also arrays, structs. There's also void, which means that you're not going to have any arguments passed to or from a function, is what that's for. Null pointer means that it's not pointing to anything. It just means here that you just nulled out, made it to where it doesn't reference any valid object. So now we're going to take a look at some of these variables, and yes, we will be taking a look at struct a little bit too. So int, this is to define an integer called myVariable, which we will refer to it a number of other times. We can also call them by constants or even unsigned. We have different options on that. These are things that we can do to, now if it's a constant, it becomes unchangeable. That means it will be stuck. If I take that as, you know, if this is float, if I take this and make that one constant, it's never going to be able to be changed. I cannot assign to it. It will create an error if I try to assign to it. And then unsigned means that it's taking the last, or rather the first bit, that when it's signed, that first bit tells whether or not it's positive or negative. If it's a 1, it's negative. If it's a 0, it's positive. And then unsigned means that we're taking that away, and that bit is now a part of the number, allows for a little bit bigger of a number to be used. So just a different format of the same variable, but in this case, yeah, we're dealing with a float. And we had that. And in this case, we can assign them all, we can do a multiple assignment from one. We have the number, and we just assigned it to both of these guys with this statement. That's what that means. To be able to create a struct, we're going to take a pause from these variables down here. We're going to take a look at struct. Actually, that struct should not be there at all. You're going to define your type, and then you're going to find the variable that it is. And then in that case, I'm going to assign values to it. And these will be given in the order comma separated if I had additional members. But remember, we only had the one member for struct up here. It was just an int called num. So that means it's going to set num to 1. Now if I had anything else, I would hit comma and whatever its value would be. And that's how I can easily set up a struct. Or I could just set that up and then call each member and set each one individually, however I choose to do that. This is certainly an easier way to do that, to use the curly braces and load it like an array. It's kind of like an array, except for they can all be different types. And it's in the order of which they appear in the struct declaration. Now, these are two more ways of changing, modifying these variables. In this case, I'm going to take my variable, and this is increment. That means I'm going to add 1 to that. So that would make my variable 4 at the end of that statement. Over here, I can take whatever value I want to. In this case, I have a literal 1. I could use any other literal. I could use a variable, and that's going to be the same as my variable equals my variable plus whatever that is there. That's just another way of saying that. It's a shorthand way of adding something to that number, and in that case I can use other than 1. So in that case, at the end of that, it would be, my variable would be 5. Now the format specifiers that we were using in our print, and it also counts over there in our get up here, different ones are used for different things. And that's where we're going to see it down here. I have a multiple print. So if I have an integer, where is that critter? There's one up here that's for assigned int d. So that's going to take, whenever I print this is print formatted, and it's going to print this string. That /n means a new line, and each of these percent something is going to be the associated type. So float is %f, %d, which is for assigned int. It's going to replace them in order. These additional variables need to be placed in order of what they are. Since this is a float, it went last. It went last in here. So if I am going to reword that sentence that I'm writing out, if I want to say my other variable is and my variable is, then I also need to reverse these two, because these need to be in the order which these guys appear, and they need to fit. That's how they're formatted. They will be formatted according to what variable type is supposed to go in there. Arrays. This is a multidimensional array. So we have two, on the first dimension we have 2 arrays of 3 each. So here it is. We have 2 arrays separated by that comma, and they're each 3. And that's what that would create. So my first array would be, if I'm calling this and this is a 0, I'm going to be calling into here. And then if that's a 0, I'm going to be calling there. This is a 1 here. If this is a 1 and then this is a 2, I'm going to be calling that 6 out of it. But that's how I just kind of create a matrix like that. It's a multidimensional array. But you can create any number of dimensions with those arrays. That's how those arrays work. And we do get a chance to revisit arrays a little bit further down. Certain operators as well to be aware of. Size of tells the size of a variable in bytes. And in this case, this would be my variable, which I think was int, which I think was 4. I think, where are you? My variable, int my variable, which I believe was 4 down here. Yes. Either 2 or 4, depending on what I have loaded into it. Now, if I wanted to get, and that's one of the things that makes C and C++ really awesome, is I can sit there and play with memory addresses and not be dealing directly with the variables. It saves time, which those little elementary things that you do, if you're doing a lot of action, that little bit of, using a memory address as opposed to a reference and handling that manually, it can make a difference on your speed, a significant difference. So if I had the ampersand before my variable name, that's meaning getting the address of that variable, not the value of the variable. This would be to define a pointer to my variable. So this is going to be a pointer. This is defining it as a pointer, and then this is the name of my pointer, and then that's going to be, set that to the address of. So I'm basically taking the address of my variable. That should be my variable on there, not my address. And then, so it's going to take, and then it's going to take that and put the address of this into here. And so I've just defined a variable that can take that. So creating a pointer to a variable, and then this is to pull the value of the variable from the pointer. So you would take that pointer to your variable, put the star on in there, and that's a dereference operator. That tells it, okay, I'm looking for what's the value. I'm no longer calling it as, I don't want the address, I want the value of what's there at that address, what's stored at that address. Word on control structures now. Alright, in our case we're dealing with, we defined int a, and here we come. We've got if, else if, and else. So this is equal to, and of course we can put a exclamation mark in there to make it not equal to. If we want to do not equal to, we can also do not, so that way it compares as equal to, and it's getting the not, the reverse of that. You can also see we can use less than or greater, less than or equal to. We can also use greater than or equal to, or just greater than or less than. Got all kinds of options. And right here, we're going to check to see if a is equal to 0. If it is, we're going to print 0. In this case, I don't need any extra arguments over here because I don't have any format specifiers in that string. I'm just sending out a string literal. Now I'm going to, so it's 0. Now this is checking to see if it's if a is less than or equal to 0, and it is equal to 0. But because this ran, this is for else if. If this runs, nothing else runs. It's only going to run one of these guys in here. Since this one was true, it's going to ignore this. But if it was not 0, this would have ran. So that was only in there for academic purposes. This would print that it's negative because it's less than 0. And then if it's not 0 and it's not negative, it's got to be positive. So we have else positive. Now we're going to take a look at another way that we could have said that, and there's actually a couple of other ways that we could do this, because these are just expressions, but in our case we're actually able to run them on C. Some languages where this appears, you don't run them, but it worked. When I did the tests, this worked on C, so we went ahead and did it. But this is one way to take a kind of a shorthand if-else. So if this is true, it's going to do 0. If it's not 0 over here, if that's false, then it will do the next thing, and it will say print non-zero. But normally what you would do is you would assign, you'd have your variable here, you'd have your string equals, and then these would just be variables that would be returning something in each one of these. That's generally what you do. But C seems to take the executable just fine. But many other languages, you would do it differently. Alright, now let's take a look here at switch. Switch is an option which you can use, and you can create as many of these guys as you want to and have these be like 1, 2, 3, but I just entered 1 so that way we can see. But that's the point behind there. So it's going to take a look in here, and it's going to take a look at A, and it's going to compare it to each of these cases. Is it 0? Yes, it is. So it's going to print this, and then we got to break out so that way it doesn't come down here to default. It doesn't try and compare against other cases. The first case that matches, we can run that. We can break from my switch block. If that did not match any of my cases that I had, it's going to go to default, and in that case it's going to print this. And since this is the last item in here, I don't need a break after it. There's also continue. So break breaks me out of any type of iteration, or it breaks me completely out of that control block. If I use continue, there's also a command called continue, which is similar to that, and it only resets, it bypasses the rest of that iteration. So, let's say I've got multiple statements down here on this for loop that's supposed to be looping. Let's say I got multiple of them in there, and halfway down I put a continue. I create a condition, and then that starts, if some condition is true, continue. Once that continues hit, everything below that is not run only for that iteration. It will continue with the next iteration. If that was a break, it's going to simply break free completely and not run that loop anymore at all. So let's take a look here at for. For in this case here, we have the parenthesis and we have the curly brace. Curly brace is the code that's going to run as long as we're running this loop. This guy here is going to run the first time. It's only going to run the very first time at the start of running this loop. And then to determine if we're going to continue running the loop, it's going to check this comparison. If this comparison is true, it continues to run. If it's false, it won't allow it to run anymore. Between the loops, but not on the first time, it will run this comparison here just before it's going to go back and compare this. I mean, it's not a comparison. It will run this statement. So here, I start at 2, and each time this thing runs, it's taking off one of that, and it's checking to see that it's still over 0. So I'm going to have one that would be printed out as 2, and then I would print out another line. This is once again, you got one of those format specifiers. So it would print out on one line, it would print out 2, the next line it would print out 1, and then it's going to come back through and it's going to say, nope, it's not greater than 0, it is 0, so I'm exiting. And then it's going to come down here and run the next. Now, this is a for each loop, and this is only allowed in C++. C does not support this on its arrays and whatnot like that. So in this case, what we have is, this is the type of the iterator, and this is the iterator itself. So this is the name of the iterator. And this is the array, as strings are character arrays. So I'm going to pull each one out and put it on a different line. This would give me a capital T on the first line, an E on the next, an S on the next, and a T on the next. As it's going to run this loop one time for each character in there. It's going to run it once for T. That char is not my char, is going to be that T. It's going to be passing it a T, putting out T with a new line. Next time it runs, gets the E. Next time it runs, gets the S. So on and so forth. Till finally it's out of those, then it breaks out. We're going to take a look at while and do while, which are very similar. In this case, as long as whatever's in the while parenthesis is true, it will continue to run. To avoid looping forever, we need to modify that and make sure that it's moving closer to the exit, or whatever we do for that. But as long as this condition is true, it continues to print out. In our case, it's printing out that line with whatever that A is. So, you know, in our case here, it's 0 when we started, so it's going to print out as 0, and it's going to bump it up 1. This is increment. It's going to run through there. It's fine. It's a 1. It's still less than 2. It's going to print out a 1, bump it up 1. Gets to here. It's a 2. It is not less than 2. It is 2. Bumps out. Does not run this. Comes down to here. Runs starting here. And here we just move the comparison down below. By doing a do here, I can put my while down here, and that allows me to know that this is going to run at least once. The curly braces will run at least once, and then I have the chance to break out at the end of each loop. Minor difference, but sometimes those little differences mean something. Now, exceptions, surprisingly enough, even though they're so simple in C++, C is too simple for it. Does not support exceptions in C. This is a C++ feature only. And I think I mentioned that too. The for each is only allowed in C++. So C++ only for exceptions as well. You've got to be using C++ to use that. So for your bit of performance that you're going to get, you're paying for it and stuff that you can't use. You know, some of these tools, some of these classes, these exceptions, these, you know, iterations for each. But in our case here, we can actually throw anything in C. That sounds kind of crazy, right? You know, just pick up anything and throw it. But whenever you want to throw a fit about what you don't like in C, then you can just throw it. Hey, I don't like my 5, I'm going to throw it. Try is the block where things can be thrown from. Anything which you want to have a fit about, throw it from the try block. If it's thrown outside the try block, then it's going to raise an error. So any type of function that you're going to run, or if you're thinking that you might want to throw an exception for some reason yourself, do it in a try block, because then you can handle it. And down here on catch, you enter different types, and whichever one matches first on the type, you're going to be able to run the code down here to handle that inside there. And then the ... means you're handling the code for any other error. And no, finally is not supported in C++. Try, throw, and catch are not available in C. C is, I guess, too civilized to throw a fit, but C++ gets rowdy. I don't know. So we're coming down here, we've got our functions. And so calling of our functions, we can we have our option to call whichever way we want to. We can call, if we call a function that has a variable with it, and that's where we overloaded it, and that's the reason why I put the functions down here, is that way we can look at that. See, I have one, and we can also see too, this is the pass by reference operator. Normally it's passed by value in C, but in the case here we have an ampersand, so passing an integer by reference is what we just did here. And then we just happen to return that thing right back, so it gets two copies. You know, it keeps the old one and gets the new one. It's kind of as silly here as assigning it to the same variable that we called it from. But the determination on which one it calls, if it does not have a value in here, it's going to call the one that calls for void in here, that it does not take a value. So this one would run for that function call. Down here, I have the same name called again, but I have an integer. That was an integer that we defined it as, and it will be called, and therefore we're returning a value, so we're ready to catch that value and put it in a variable. So yeah, that's functions, and that's function overloading. And you're fine to use functions in C, just don't overload them. You can only have one function per name. And also, yeah, optional parameters too. You know, I could also have an optional parameter here that would make that optional, but that's also only available in C++. Can't have optional parameters in C, and cannot have functions with the same name, even if they have different signatures. Just one name and one name only, so you've got to send everything through to it with C, or have it be named something different. Alright, classes. This is where we're going to get into the last little bit, but it's going to be a lot to look at in here, because we got to go up to the top where the class is defined. In our case here, we're going to define, this is defining the type, and this is calling the new class with its constructor. So we also called it with a parameter for that constructor. Now we're going to take it out here, and we are now we're calling the public field back and printing that out, which is a type integer. We will see that later on. So I create the class as a constructor. We would call that public field to get this. We'll show how we create a class in the next few minutes before we exit out of this. And this is returning a 0, meaning that I did not have an error to whatever started my application, bash, or I could return non-zero indicating an error. But most things don't even check for it anyway, so yeah, return. And that's why we have that int, right? Up here at the start, we said int main. That's what we're returning. And then if we're not returning a value, we can just say return, or we can return the value. Now we're going to take a look at class. We already talked about namespace, so we don't need to discuss that again. A class, on the other hand, though, we do need to talk a little bit more about. So, class and then the class name. And then you could put a colon and then a modifier and whatever class is going to inherit, a comma and another modifier and whatever other classes it's going to inherit. And it can inherit multiple classes, any number of them that you want to inherit on C. Now, what's up with that modifier? We're going to talk about that in just a little bit. We got 3 modifiers available to us in C: public, protected, and private. Public is everything is accessible to everything else throughout the program. And if we have something that is protected, then that is available only to children of that class. And if we have private, it's not even accessible to children of that class, to derived classes. So this would become a child class of whatever it inherits. You know, it inherits from class. This would be the type of class. So if I had my other class defined somewhere else, I could make this a child of that by saying colon and however I want to inherit that, which changes all of its members. That's what that does. So we'll talk about that when we get further in. Public. We basically, C is the only one I've seen that it does this, where you have a section defined. Everything beyond public down here, so all of this is all public. Everything down here is protected. Everything down here is all private. And so I can have private variables and private functions. And basically when you inherit a class, the members from that class, kind of like what I mentioned as far as what these guys are, as far as public being accessible to everybody, protected being only the children, private being for them, for the individual class itself and not accessible even to derived classes. This sets a maximum. This modifier, these modifiers here are for the maximum. For everything that's inheriting from that class, what is the maximum visibility for that? So if things were private in that parent class, it's still not going to be accessible here. But things that were protected will be accessible here but private within here. And things that, if this is public, it's going to allow whatever that is to be adopted directly. Things are all private by default, so you want to make sure you mark your public stuff what you want them to be. But if you don't specify them, so if I had anything that was probably above this, if I'd stuck stuff up in there, private. It's not specified yet. Alright. Here we have public, and yes, your class constructor and destructor are in here. They've got to be public to work. So yeah, we can have protected fields and protected methods, public fields and public methods. That's what we have up in here. And so this is the class constructor. It's just named same as the class, and it doesn't really need to have a return type because it's not going to return anything. Same as the destructor, it's the tilde and the name of the class. It will never take a value. Over here on my class, I can overload that function. Yeah, I can do as whatever I want to do in that way of having stuff in here, and then I can take that, like in this case I'm loading public field into whatever that new value is, whatever was passed becomes that new value. So just a quick look too at encapsulation. Everything that's over here in private only functions inside of my class can access stuff that's in private. If I derive this class, if I derive another class from this, then they can also access protected members, which means whatever's down here I can set it from here. I could create this method to set whatever's down here, but that's the only things that can mess with that. That and my protected methods and stuff like that. Everything else, I know it's not going to mess with that. So that's a good overview, I think, of C versus C++ and their differences and how to code.
Thank you for watching.